Subroutines. Subroutines, aka routines, subprograms, procedures, or function, may just be the important building block of a good code. They are the most basic kind of code abstraction. So, a subroutine is also called a subprogram, is an abstraction of a process that is called. The caller passes arguments to the subroutines which accepts them as parameters. A function returns a value or values and is called from within an expression. A procedure returns no values and is called in a statement, not an expression. A method is a subroutine defined on an object in an object-oriented context. So, ang subroutine is an abstraction called of process that is called. O, ang caller passes arguments to the subroutines which accept them as parameters. So, ang function returns a value of values and is called expression. An procedure returns no value is called a statement, not in an expression. And last, the method is subroutine defined as an object in an object-oriented context. Something like in the presentation below. Note that in many languages, parameters don't have types, nor does the return value. The set of modes differ between language but are usually things like in, out, alias, reference, and value. Signature matching. The point of signature is to distinguish legal calls from illegal calls. Languages differ wildly in how they define whether or not a call matches a signature. So the example is, do the parameter names matter? Does the order matter? Do the types matter? Does it even sense to put type restriction on parameter? Does the number of arguments in the call matter? What if we pass too few, too many? How do the modes affect that what can and cannot be passed? Do the return types matter? Can the subroutine be called as part of statement or must it is called in an expression? Can the subroutine be called as part of expression or must be called in a statement? Hey, I want patterns for my parameters rather than specifying them directly. Very static language have a rule like k equal to n, and the type of each ei must be compatible with the corresponding ti. But many languages have many different rules. Yes, defined whether or not a call matches a signature.
Parameter association. Positional and name association. Virtually every language supports positional association. The first argument goes with the first parameter. The second argument goes with the second parameter, and so on, and allows both positional and name association. The order of the name arguments don't matter. You can mix the two styles, but the positional one must go first. So, pwede zani mo matipo, pero kinahanglan jud nga ang positional mo ay mauna. Then, Python is the same. It calls the name ones keyword arguments. In Ruby, you mark the parameters that must be named with a colon. So, overloading. With overloaded subroutines, the compiler has to figure out which subroutine is being called. This is called overload resolution. Default parameters, super common. Some languages have de facto defaults. If you don't call the subroutines with enough arguments, the missing parameters automatically get some kind of undefined or null value. Then periodic subroutines. A periodic subroutine can accept an arbitrary number of parameters. In LISP, you make a function periodic by marking the last parameter with and rest. In Perl, all subroutines are periodic, since all arguments are collected into the array. In Java, you can mark the last parameter of a method with double quotation to mean that it is really an array and the caller can pass in a variable number of arguments without the clunkiness of putting them in an array. Python is similar. A parameter prefixed with exponential collects that extra parameters into a list with exponential. The extras are collected into a dictionary. In C, you need the stdarj.h library module and a lot of code.
Patterns. In JavaScript and function declaration don't necessarily have pattern parameter, and they have path. The JavaScript has both array patterns and object patterns. How many returns value can subroutine have? 0.1 many. Perl any number. In the ML family, exactly 1 to get 0 points to return unit. To get more and return a tuple. Most other language, 0 or 1. What kind of objects can and cannot be returned from a subroutine? Algol 60 and Fortran scalar only. Pascal scalars or pointer only. Ada 83.c anything but an actual function and true pointers to functions. Ada 90 point modulo 3 can return closure to. Most dynamic language can return anything. Point. How are the return value specified? Pascal and Fortran. A special variable with the name of the subroutine gets assigned. If it has a variable called result in SR and you declared the result variable in the subroutine signature, most other language an explicit return statement called also with the last expression in the body e.ig, Perl, and Ruby, many others. Argument passing. Passing argument to parameter looks so simple, right? Common mechanism. People have identified a bunch of mechanism other time. In Kali, can write to the parameter out. Kali can read the parameter is to send the value out
at the end. In out. Kali can read the right parameter, change to parameter are reflected in the argument, but we don't know if the argument sees the update during or only after the execution of the Kali value. Argument value is copied to the parameter. Change to parameter are not reflected in argument. By value of result. Argument value copied in parameter value copied out at the end of Kali. Aliasing, sharing. Argument and parameter are one. Change to parameter. Immediately are seen the argument because, as was just mentioned, the argument and parameter are one. By reference, an implementation of aliasing through passing the address of the argument. By name, parameter is more or less a macro taking on the source code text of the argument. Generic subroutines in a statically type of language. How can we say that a parameter can be passed arguments from different types? In C++, had added the compiler generate code for every instance of a generic subroutine in C++. Each actual subroutine is implicitly generated when needed.
So here's an example of a Java generic method. Subroutines as values many times, especially in event-driven systems such as GUIs, event-based servers, or asynchronous messages senders. We need to call subroutines and directly the actual subroutine. Closures. In your language, let's you store one subroutines as values and two nest subroutines. Then you can make closures. A closure is a subroutine that refers to a variables defined in an enclosing scope. Subroutines as argument. At first glance, passing subroutines as arguments doesn't appear to raise any scoping problems.